Hey, what's up? It's Joel Powell, Mr. Cook, and we just finished up the first page of the Unit 6 group work on right triangle trigonometry. I'm going to flip the page and start working on the word problems and solving the triangle. So solving the triangle is just combining the last couple problems that we worked on, finding the side lengths, finding the angle measurements. It's just that some of them are going to be like kind of freebies, because when you're solving the triangle, you're finding every single side, every single angle. So let's look at the ones that we're missing. We're missing angle A. So the measurement of angle A. We're missing the side length AC, so let's put AC there, and then also BC. So those are the three that we need to find. One we can find right off the bat pretty easily is the angle measurement A, because this angle and this angle and this angle, since they're in a triangle, they need to add up to 180 degrees. So if I just take 180 and subtract away 90, that's 90. And if I subtract away 48, that gives me 42. So I know that this angle is exactly 42 degrees. There's no rounding or anything like that for this one. That's the answer for it. The other two, however, BC and AC, I'm going to have to find approximated answers. So I'm going to change it to the approximate equal sign for those ones. It's just because I'm going to be using the trig ratios to solve, and so they're not going to be exact answers like, you know, what I would find with a rule like the sum of the triangle angle measurements, or, you know, over here we'll see with Pythagorean Theorem we can find an exact answer as well. Anyways, so relative to this angle, I'm going to look for the adjacent side first. Let's call that BC side X. So if it's the adjacent side and I have the hypotenuse, that's cosine. So I can use cosine of 48 degrees to solve for this, this angle, this side length X. So it's the adjacent side X over the hypotenuse, 7.7. So to get X all by itself, I would multiply both sides by 7.7. So X, in other words BC, is equal to 7.7 times the cosine of 48 degrees. So I just type that into my calculator and I have my side length of BC. So 7.7 times cosine of 48, and I get 5.12. Now, I want you to also notice that 5.152, sorry about that. So 5.15 would be our answer. And I want you to notice that we have units here, inches. So just make sure to put inches for your unit on units on BC as well. AC is the next side length we need to find. Let's call that Y. So relative to this angle, that's the opposite side. So we're looking for the opposite side. We have the hypotenuse, so that's sine. So the sine of 48 degrees is equal to the opposite side, y, over the hypotenuse, 7.7. So once again, very similar to how we solved this one. We just multiply both sides by 7.7, and we get y is equal to 7.7 times the sine of 48 degrees. And then once again, just plug it in your calculator, and you've got your answer. So 7.7 times the sine of 48 degrees, and we get 5.72. So that side length AC is going to be 5.72 inches in length. So then we've got all three of the missing parts, and we are done solving the triangle for number 15. All right, now let's move on to number 16. Let's label the things that we need. We need the measurement of angle A, we need the measurement of angle B, and we also need the side length AB. So the one thing that we can find the exact measurement of is the side length AB, because we know that there's a relationship between the three sides of a triangle, that's of a right triangle. That's Pythagorean theorem. So if we just use Pythagorean theorem, we can find that missing side. So I'm just going to do that real quick. 8 squared plus 13 squared equals x squared. Let's call it x. There we go. So 64 plus 169 equals x squared. And then 64 and 169 makes 233. And then if you take the square root of both sides, you get x is equal to the square root of 233. And let me think. No, not divisible by 3. I can't think of any things that divide into that real evenly, especially any square root numbers. So I bet it's like, more or less prime. So, I don't know. I just leave it as that. So the exact value of it is the square root of 233. There's no reason to plug it into your calculator or find any decimal value equivalent to it. It's just square root of 233 is good enough. Now, these two angle measurements, A and B, we're going to be using trig functions to solve these, so they're not going to be exact answers. They're just going to be approximated answers. But let's say that I want to solve for angle A. Relative to angle A, I know the opposite side is 13 and the adjacent side is 8, so I could use tangent inverse for that one. So tangent inverse of the ratio 13 over 8 is equal to my angle A. So if I type that into my calculator, tangent inverse of 13 over 8, I get the first angle measurement, 58.39. So there we go, that's the first one, 58.39 degrees. So one way you can solve for the last one is just by subtracting from 180. So 180 minus 90 minus 58.39, you get your angle. What I like to do instead, just because it's a little bit more efficient, is to recognize that, like, if I wanted to solve for B, it'd just be the same ratio, tangent, but the opposite side would be 8 and the adjacent side would be 13. So B is equal to the tangent inverse of the opposite of the ratio, the reciprocal. So 8 over 13 instead. I mean, I'm going to get the same angle measurement, but it's like a little bit faster than subtracting even in some cases. So 8 over 13, and I get 31.61 degrees. So again, it's the same number that you get by subtracting, but you'll find that it's actually like kind of a little bit easier to do it that way when you start doing more and more of these problems. Anyways, so that's solving the triangle for number 16. Now we'll move on to the word problems, 17, 18, 19, and 20. So you're going to find that, by and large, the majority of the ways that we're going to solve are just through here, finding angles or finding sides. That's all it's asking you to do. So the hard part really is drawing the diagram. So if you struggle with drawing the diagram, look for keywords. So let's read through it. 2 helicopter pilots hover over a car accident on the freeway. Both helicopters are hovering at an altitude of 750 feet. So that's the height that goes straight up and down. But on opposite sides of the accident, so they're on either side of an accident that we're going to draw in a second. From the accident scene, one helicopter is hovering at an angle of elevation of 63 degrees, and the other is at an angle of elevation of 51 degrees. How far apart are the helicopters? And then round it to 2 decimal places. So let's draw the scene a little bit. So we can draw like 2 little cars that are kind of like maybe in a fender bender. So there we go, there's one car. And then maybe it like hit a truck or something. There we go. So ran into a truck. And then the 2 helicopters are over on the left and the right-hand side. So let's see here. There's one helicopter. And let's draw another helicopter on the other side of the accident. Okay, so there's our 2 helicopters. So let's that's the part where it says that they're on opposite sides of the accident. See, they're on opposing sides there. From the accident scene, we have an angle of elevation. Now remember, the angle of elevation means that it's like from a ground position or a lower position looking up. So that's why it says from the accident scene. Our perspective of the angle is actually from the accident. So, leading up to the helicopter and then also from ground level, that makes one angle measurement, and that's going to be one of our angle of elevation. So for one of the helicopters, it's 63 degrees. And then also we know that the elevation or the altitude of it is going to be 750 feet. So the helicopter is up 750 feet. So it makes like a right triangle for us. And that's why it's, in this section with right triangle trig, because we can find all those side lengths now that we know this little triangle. Very similarly, an angle of elevation leading from the accident up to the helicopter of 51 degrees. So our other angle that makes with the ground is going to be 51 degrees. But it's the same altitude, 750 feet. So we have 2 different triangles, and we need to find how far apart the helicopters are. So in other words, this distance from here to here. So if we want to find that distance, D, let's call it D, it's the same as this distance. And we can find this distance by finding this part of the distance, this side length on the triangle, let's call it X, and this side length on the triangle, let's call it Y, and then just simply adding them together. So if we add these 2 together, we get the distance between the helicopters. So let's find each of those individual distances. So I'm going to start by drawing this triangle separately just to kind of make sure that I know exactly what I'm looking at. So we got a 63 degree angle here. I know this side is 750 and I need to find this side X. So relative to this angle, I have the opposite side and I need the adjacent side, that's tangent. So the tangent of 63 degrees is equal to the opposite side, 750, over the adjacent side x. Now solving for it, just switch these two values around, so I get x is equal to 750 over the tangent of 63 degrees. And then that'll give me my x value. Similarly, I've got this triangle for y, so it's a 51 degree angle this time instead. The opposite side over here is 750, and I'm looking for the adjacent side y, so that's tangent once more. So the tangent of 51 degrees is equal to 750 over y, and then solving for y, I get y is equal to 750 over the tangent of 51. Then it's just calculator time. So let's see here, 750 over tangent of 63. That gives me 382.14. And let's do the problem over here too. So 750 over the tangent of 51. That gives me 607.34. And then I just add these two together, and that'll give me the total distance between the two helicopters. So let's see, let's add those 382.14 plus 607.34, and we get approximately 989.48 feet. And there's our answer. All right, so that's the first word problem. Looks like we're creeping up on 11 minutes or 12 minutes for this video. I think I'll do these three on another video. So that's it for this one. So we're just gonna do first three problems, then we'll do the last three problems on the next one. So yeah, see you on the next video.